Okay, so now we're going to have a look at how the structure of the atom was. How do they come up with it? So in a previous couple of simulations, we looked at this. This is the basic diagram of an atom, and we talked about the mass number, the net charge, and so on. We also looked at this one where we saw the size of an atom compared with everything else. If we zoom all the way out a little bit, eventually we'll get to a nucleus. Eventually. Well, I think we've got that saved on a video somewhere. We get to a nucleus and we keep zooming out and we'll get to the actual atom. So we see that actually an atom is mostly empty space. But how do they come up with this theory in the first place? So these are the two prevailing theories at the time. It was the Greeks that many thousands years ago, thousands of years ago, came up with this. They coined the expression atom, or we stole it from them, maybe. And they used the expression atomos, atomos, and it means indivisible. And they had this theory that all matter is divided into these indivisible chunks, and they called them atoms or atomos. And we continued with this idea. Now, it turns out that actually atoms can be divided into protons, neutrons, and electrons, and even the protons and neutrons could, in theory, be divided again. However, we've kept the word atom anyway. So, plum pudding atom is basically this idea of this big sort of blob of matter that's fairly what we call amorphous, which means it's not particularly hard, and if you had something that was reasonably hard being fired at it, it would just go straight through it. Whereas the Rutherford atom is a bit different. It's got the nucleus in the center, which is quite hard and solid and contains most of the mass. And then you've got this big space around the outside where the electrons would be orbiting. By this point, they already knew about the electrons. And the plum pudding people, they said the electrons were stuck inside the atom like plums in a plum pudding. And we don't really eat plum puddings nowadays, so maybe you could think about it as raisins in a bun. But and then the rest of the atom was the positive charge, and so they knew that they had a positive charge and they had a negative charge to cancel out with one another, but they weren't sure about much else. So let's do an experiment on a made up plum pudding model. They discovered these things called alpha particles. I don't think they really knew what an alpha particle was, but they knew it was very, very heavy and very, very tiny. And they made a thin sheet of gold. Now, obviously, because it's made out of atoms, then we would expect lots of tiny little atoms there. And when we press that, we should expect this kind of thing happening. All the alpha particles just fly straight through the atom, and when we detect it on the other side, we would detect just a load of alpha particles going straight through this thin gold sheet. You can click on the traces, and you can see that fairly boring just goes through straight like that. You can actually increase this energy of the alpha particles. I think they just go more slowly, quickly even. There you go. The energy increases their speed. So what did they actually see? Well, they actually saw something a bit like this, in fact. So basically, they didn't see this, by the way. They just inferred what was going on. So they noticed that some of the alpha particles were being deflected and being detected off over here. Most of them were going through, in fact, but some of them were being deflected. Some were, in fact, coming backwards, which is really quite surprising. And if you have a look here, you'll notice some are actually being deflected slightly backwards. And those few that are deflected backwards are the ones that are just are basically heading on dead on towards the nucleus. If we look closely at just one of them, you'll see a little bit more what's going on. You see these ones that happen to be head on, they're the ones who are turning direction. But the rest of them are just being deflected. So that's actually what's going on. They don't actually hit it, they just get deflected by it.